Alright, chapter 5, we are starting to get into one of my favorite chapters, the trig stuff. And it takes a little getting used to, so these first couple sections, if it seems like it's taking a little bit more time to catch on to it, that's fine, that's common. So for section 1, the first day anyway, we are simplifying. And like I said in class, you really don't know where to simplify to, so a lot of times I suggest that you look up the answer ahead of time and then try to simplify to that particular answer. So I'm just going to do 3 random simplifying problems, ones like that you'll have seen somewhere in the homework. So the first one, I'm going to give you this. And like I said, look in the back of the book. They tell us that I'm supposed to get sine squared of x. When we get to the quiz and we get to the test, realistically you won't have any problem. Section 1 and Section 2 are the same thing. Other than Section 2, you know what the answer is ahead of time, so you just have to get to it. Alright, so when you get questions, really Section 1 and 2 are virtually the same thing. Alright, so I need to look at my fundamental theorems that we wrote down the other day and say, can I get this to look like that? There's good and bad news. Good news is there's more than one way to get to that answer. Bad news is there's plenty of wrong ways to do it. You just have to be careful. Make sure that when you are, whatever step that you're about to do, that you use one of the identities that you know. As long as you're using an identity that you know, you will eventually get there, as long as you don't make any algebra mistakes or any mistakes with your identities. Alright, so what do I look for? Like I said, I look for quantities where you've got 90 minus theta. I look for any sort of squared function, which I see here. That's a clue that I know there's identities for them. So any kind of squared function, first thing I might do is say, well, there's an identity for that. Can I switch that? So you can go up and look at your Pythagorean identities, and you can look and see that, yeah, sure, there's an identity for that one. And I could switch the tangent squared into something that has secant squared in it. I could switch the secant squared into something that has tangent squared in it. Or what I might notice, and again, this comes with practice and being able to recognize certain things, I could change these into sines and cosines. It's one of the strategies I have, and get some stuff to cancel that way. So that's what I'm going to do, is I'm going to take tangent squared and change that into sine squared x over cosine squared x. Again, some of this comes with practice, and once you get used to doing it, you'll understand what to kind of try first and what not to try, but it takes time. Alright, divided by the secant is the reciprocal of cosine, so that's 1 over cosine squared x. And now I have a complex fraction, so I can multiply by the reciprocal. So I have sine squared over cosine squared. Multiply by the reciprocal, that means the cosine squared is going to the numerator. The 1 goes to the denominator. And of course now I can see these things cancel, and sure enough that is going to simplify into the sine of x squared. And so I got my answer. Again, is that the only way to do it? No. That's probably the quickest, nicest way to do it. At least you can try other things. If you looked at this and you said, well, I know that tangent squared, according to my Pythagorean identities, is equal to secant squared minus 1. You could try messing around doing something like that. Eventually, you will get to sine squared. It just might be a little more messy. So here, I'll show you for example. Let's say I change that into secant squared x minus 1. So I change tangent squared x into this, divided by secant squared x. Now I look at that and say, well, now I really don't know where to go. Well, one strategy, and again, you'll think to use this strategy the more familiar you are doing stuff like this, is I have 2 terms in the numerator, 1 term in the denominator. So it's kind of like when you have this, 3 plus or minus the square root of 5 divided by 2, how you can split them apart and divide them both by 2 separately. I can do the same thing here. I could say that this is secant squared x over secant squared x minus 1 over secant squared x. And you might look at that and say, I don't see how that's helping me. Well, what is that actually equal to? Well, that's 1. 1 over secant squared. 1 over secant, the reciprocal of that would be cosine. That's actually 1 minus cosine squared. And sure enough, if you go look up your identities, 1 minus cosine squared is equal to sine squared of x. So like I said, there's more than one way to do this, so don't feel like if you're doing it one way and your neighbor's doing it a different way that you're doing it wrong or they're doing it wrong. You might both be doing it right. Alright, let's look at the next one. Next one's asking us to simplify the cotangent of the quantity, basically 90 minus x, times the cosine of x. Again, the first thing I suggest that you do is look up the answer. So for number 38, let me take a second here and see what the answer was supposed to be. It's supposed to be sine x. So we are supposed to get sine x. All right. So again, what am I looking for? Well, I a lot of times am looking for a trig function squared. I don't see that. Next, I'm looking for something like that. Do I have a 90 minus theta? We don't use this one very often, but I'm looking for something like that. If I didn't see that, I would be looking for a negative angle. So for example, do I have something like that? Those are three specific things that I look for, and I know there's identities for them. If I don't see those, then a lot of times I'm going into switching stuff into sines and cosines. But I do recognize that. So if you don't know what cotangent of 90 minus theta or 90 minus x would change into, you can go and look it up in your identity sheet, and you'll find out that that's actually equal to tangent of x. So cotangent of pi over 2 minus x will change into tangent of x. And now you might be able to see it, especially after the first one we did. I'm trying to get sine. I know this can change into sine over cosine, which will get rid of that. And all I ask that you do is please show it. Don't just see it in your head and say, oh, yep, this equals sine. No, I want you to actually write this out and say, yep, because those cancel, now I've got sine x. So it's really important that you do that, because although you might be able to think 2-3 steps out, I can't see that, and I need to be able to see what you're doing when I'm grading it, especially if you make an error. If you said to yourself, oh yeah, this is cosine over sine, which isn't right, so that changes into cosine squared over sine, or whatever the case may be. If you make a couple of mistakes, there's no way for me to follow it. So please show that, even though you know that that probably is going to go right to that. All right, the third and last one I'll do for day one is simplifying this problem. And again, you're going to want to take a look at the answer so you know what you're simplifying to. And the answer for that particular problem is secant x, or I guess it's t. If it bothers you to using t or theta or some of the goofy symbols that they use, you can always use x or theta. Try to use it. It shouldn't give you that much of a problem, but if you don't like it, it's not the end of the world if you use x all the time. All right, so what is my eye drawn to? Well, I see that's no big deal. It's a positive angle. It's not 90 minus theta. This is what draws my attention. It's tangent squared. Because it's squared, I know I can use a Pythagorean identity. Changing everything in sines and cosines is a good strategy, but usually it's the last strategy you want to use. So I see tangent squared. So I go and look at my Pythagorean identities and find the one that's got tangent squared in it, and I recognize that tangent squared plus 1 actually changes into secant squared. So that parenthesis changes into this. Well, I also know that by doing my reciprocal identities, that secant squared is really 1 over cosine squared. I've got two cosine functions here, one here. That one will cancel with one of them in the denominator. That leaves me with one cosine function in the denominator, which, of course, if I do the reciprocal of it, is secant. And now I've got my answer. So like I said, this is going to take some time. Don't get frustrated right away. Keep practicing, keep practicing. If you get it wrong, try something else. Keep practicing. Eventually, it'll click with you, and the more experience you get, the faster this will come. All right, that is help for day one. I'll help you with day two next time.